This is one way for you to connect the Glulam member, here to your cross-laminated timber panel, right? So there are different ways for you to do it. Okay, so this shows you the Glulam joist, okay, to the CLT wall panel, for example. Okay, so again, quite a neat way to do things. Okay, see here. These are some variations, okay, of the Glulam joist to the wall panel. Okay, some other variations. And here you can see the physical installations. Also, you can see quite a lot of the steel, this prop for shoring beam member, okay, before the installation is complete. You can see. This detail show you the combination of different connections between the wall and the ceiling location, okay, lower unit and the upper unit. Right? It may appear to be quite complicated, but actually it's just a repeat of the different way of doing the connection. Just repeat. Okay, another example of a joint, okay, where you have the wall panel, you have the ceiling panel, and then you have the wall panel at the upper unit. Okay, and how to do the connections. You can also have a upstand beam in the form of a Glulam or in the form of a steel member, okay, if you need to, right, upstand beam, okay, special connections. It is possible for you to have a cantilever, but if the cantilever length is too long, the deflection may not be acceptable. Then you may be forced, okay, to have a single column, okay, to support the corner, okay, so that the deflection is acceptable. Okay. One advantage of the timber elements over the concrete is that you can actually make openings or holes through the timber component so that they can receive the services and your services become concealed, right? You can have vertical and horizontal services that is concealed inside the timber element, okay? So the opening sizes will be as required by the services. So you can have the option where you do the holes, okay, in the factory, or you can cut the holes on site. So it's very versatile again. Yeah. In terms of creating the openings or for the services in the factory, okay, typically it is glued in. So you can have a tube to allow the services to run, okay, and the tube is actually glued in, suitable for both side visual surface, so that you can have a good aesthetic surface on both sides, okay. Vertical and horizontal laying is possible, okay. So dimension of the tube depends on the thickness of the CLT the layer, okay. But the disadvantage of this type of glue-in opening is that the side changes will not be possible, okay. But it looks very good. Yeah. Instead of gluing, you can actually do drilling, and it's also suitable for both side visual surface. Yeah. So vertical and horizontal laying is also possible, and dimensions will be flexible. Yeah. But the quality and the appearance, okay, may not be that good if you are doing a factory, you are doing the drilling on site. Okay, the best option is to do the drilling in the factory so that the quality is better. So once you have installed all the openings through the mass engineered timber components, then it's just a matter of running the services through the components. You can see here. Okay, again some examples. Okay, running the services through the components. Right. Also, this one is showing you the bathroom installation services. Now, for the cross-laminated timber or the Glulam this timber, normally you need to ensure air tightness and water tightness, which you don't really think about when you're doing concrete construction. But for timber construction, you need to pay attention to that. If not, then you find that the rooms will not be airtight, the rooms will not be watertight. Sound travels very easily from one point to another point. So in terms of the connection for air tightness and water tightness, there are different ways to do it again. Yeah, and I'm just going to go through with you briefly. Let's look at the first type of the pin connection. Okay, basically what we are saying is that if you have your this CLT panel that is going to be resting on the concrete floor slab, okay, you need to have some kind of air tightness connection or water tightness connection. So what you do is that you have a compressed preformed gasket. This is how the gasket looks like, okay, mainly used to ensure the airtight seal at the connections of the building component. Yeah, permanently flexible joint foams, okay, can also be used in some places. Okay, this one is also an example of a joint foam. Okay, or self-adhesive tape or tubular rubber seals are used more rarely. Okay, configurations illustrated below shows a few options for air tightness. Yeah, although it should be noted that these are merely options. There are different ways to do it. Okay, so that's one way. Okay, or you can run the sealant, okay, in this manner here. Okay, or instead of running horizontal, following the length of the wall, you can run in this manner here. Okay, yeah. So for the wall to the ceiling joint, again, you need to have some kind of the gasket, okay, to ensure the tightness, okay, and this is how it looks like, okay, or the tapes of the gasket, yeah, so that the air and the water do not seep through the joints. Okay, so this shows you another variation, okay, of the wall to the ceiling joint, okay, to make sure that the air do not seep through. Okay, right here. This shows you the wall-to-wall connection, okay, and you can see again it's some kind of a gasket, okay, the gasket before you actually connect the members together, right? Okay, so this is a different way of the connection, okay, but regardless of how you connect it, okay, you need to have some kind of gasket or the sealant, okay, to ensure the air and the water tightness. Right? Okay, let's see. Okay, so this shows you the interface between the wall panel, okay, the sealant panel, and the upper unit, the wall panel. So at the interface here, you need to put in some kind of a preform gasket, Okay. Yeah. Okay, so these are some accessories, okay, that can give you these are water tightness and the air tightness, the sealing, okay. So the gaskets, okay, and the self-adhesive tapes, the rubber tubes and all that. In terms of cladding system, literally all the cladding systems and the types that can be used on a normal building, we can use it on the CLT buildings, right? So application design detailing is very similar, equal to a concrete and steel structure, okay? And all the elements can be used, okay? Your metal, your timber, your this stone or brick cladding and all that, you can use it for the CLT building cladding. So very flexible design, okay. So general design rules for those cladding system needs to be obeyed, okay. Fixings need to be properly designed so that the membrane and barriers are not affected. In Singapore, just like the most of parts of the world, okay, we need to consider the effect of termite, because the termite will eat the wood, and if you have a mass engineered timber, it's a kind of wood, so you need to do some maintenance, okay, or prevention of these termite infestations. Currently, the most effective way is still through injection of poison or chemicals, okay, into the ground, and the chemicals are poisonous to the termites, so that you don't get termite infestation. However, the chemicals, even though they are poisonous to termite, at the same time they are also poisonous to other living things. So it is not really environmentally friendly. So this is one area of research where if we can have a breakthrough that can actually increase the environmental friendliness of using timber.